Hello all, another video about P1 today. This time we're going to revise all of the different aspects of power. Power is a quantity that you can define in many different ways in science, and in the exam there are actually 4 different equations for you to work out power, and so we're going to look at when might each be appropriate and talk about what sorts of questions you might get asked about them. So first of all, if we look at the beginning of P1, when we look at energy transfers, etc., we can look at power in 2 ways. The first way we can look at power as being work done over time. Now, work done, hopefully you remember, is force times distance. So work done is the amount of force a person or an object applies over a given distance. If we divide that by the amount of time taken to do that, we can work out the power of that object. So we're looking at the rate of work done. Now, work done is equivalent numerically to energy transferred. So energy transferred over time is the other way of working out power. And so we can again think about it as the rate of energy transfer. Now, in each of these occasions, we've got joules and joules as our units here, and we've got seconds and seconds as our units of time. Power, the unit, is watts. Now, work done, the alternative unit here is Newton meters. But it's more common in P1 at least for it to be given in joules. Both are correct. Now, the other ways in which you can define and work out power are as follows. So first of all, power can be given as current multiplied by potential difference. And that relates to the flow of charge and either the push from the battery or the energy transferred. Now, because that is one way of defining it, if you didn't have, for example, your value for potential difference, you can calculate it a third way. And that third way is here. You can derive this equation here by using this equation and the equation to calculate resistance from potential difference and current. And then if you use those 2 equations, you get power equals current squared times potential difference. Now, the reason I'm going through these, despite the fact they'll be given in the exam, is twofold. First of all, again, we want to look at units. So we've got watts, amps, and volts for your units. Watts, amps, and ohms for your units here. But the other reason is, if we look at these 3 equations here, this is a prime example of a time where they might ask you to calculate something and you might be required to use more than one equation. So for example, if we just look up here, they might ask you to calculate power, but they might not give you an energy or work done. They might give you a force and a distance. And then you would have to use that equation, despite that being, a smaller equation, that equation, and then divide that by time to get power. Alternatively, if you are looking at energy transferred in a circuit, you might have to derive the power one way and then use that power to work out the energy transferred if you were given a time. So as I have previously said, whenever you're doing these equations, just make sure you write out what values you have and what you want to find. That should point you to either 1 or 2 equations. And hopefully, if it's 2 equations, they would have something in common which you could use to move on to that second equation. So those are the equations for power. 2022 exams, like I said, you will be given all of these. If you are taking your exams from next year onwards, 2023, you will have to memorise those. Now, also, with power, you could be asked to talk about it with regard to efficiency. And when we talk about efficiency, we, in general, talk about the useful output over total. Now, that can be energy, or it can be power. And here we're talking about an individual appliance. We might be looking at a light bulb, for example. You might be saying that you've got something like a 90-watt light bulb, but only 40 watts of the power are used to emit light. And in that case, you may then have to work out the efficiency, which you would give as a decimal or you would give as a percentage. They might give you some sort of efficiency calculation for power and give you a time and ask you to work backwards to get energy. So just always be mindful of what you are given in the exam. But this is a nice equation. It's pretty simple. And so it's a good one to get. Now, lastly, what I just wanted to show you is an example of an exam question where it's quite a simple power calculation. However, what they can do here is they can add some extra layers of complexity that can kind of throw you off. So let's look at this one together. The maximum power available from the photovoltaic cells. Now, guys, those are just solar panels. Don't worry about that for now. The exam question did have a picture. Shown in the diagram is 1.4 times 10 to the power of 3 watts. How long in minutes does it take to transfer 168 kilojoules of energy? Now, this is a 3-mark question, which means we're not simply going to be putting numbers into an equation and getting an answer. There's going to be something else here, and there absolutely is. So first of all, what do we have? So our values we've got are power is 1.4 times 10 to the power of 3. And we've also got energy. And we've got energy in kilojoules, but kilojoules is not our base unit of energy. We want it in joules. And so to do that, we need to multiply by 1,000. And that would be 168,000 joules. Now, what we're trying to calculate is time. Now, what we should notice is that they've clearly said they want this time in minutes, but doing this calculation would give us time in seconds. And so there would be an additional step here to convert to minutes. What I want you to do now is to pause this and have a go at this question, please. So you've had a go now. What we should be able to do is just look over at the mark scheme. So the answer is 2. And as with most of these questions, if you get the correct answer, then you get the entire set of marks. But let's look specifically. So what they give you that first mark for is the identification that you are going to have to use the equation power equals energy transferred over time. And that time is our missing quantity, so we will need to rearrange that to energy transferred over power. Now, if we do that, we will get a value for seconds, and that should give you an answer of 120 seconds. To get into minutes, we divide that by 60, and that would be 2 minutes. So that, my friends, is all about power. You've now looked at power in all of the different ways that you need to for P1. The only other thing I would say to be mindful of is just really practice using those equations so that you feel comfortable in the real thing if you get a question that asks you to combine more than one equation together.